differential equations. We're in section 4.2, day 1. We're now looking at a second example. It's going to get a little bit more involved. Let's just say that you have a solution x times e to the x. It's a solution for this homogeneous differential equation. It's a higher order. So again, we're assuming that you know one of the solutions. Can you find a second solution? Well, tell you what we did in this section is we said, look, y was equal to u times x e to the negative x. Very important to realize u is a function of x. It's not some constant, some fixed number like 2 or 7 or something like that. Why is that so important? Well, when we take our derivative, we're really going to need the product rule. So we'd have a u, and then we're going to take the derivative of this x e to the negative x. Well, we would very quickly just take x using a product rule within the product rule, x times e to the negative x, but as we get e to the negative x, the derivative of that inside part by the chain rule by the negative x has a negative come out in front. And then we'd have the derivative of x, which is just a 1, times e to the negative x. So at that point, please realize we just took the derivative of this x e to the negative x. Now we have to take the derivative of our first part, which is u prime. So that's u prime times x e to the negative x. Let's do some distributing. And we'd have a negative u x e to the negative x plus distribute over here u e to the negative x plus u prime x e to the negative x. And right now we need to take a second derivative. As we take that second derivative, here we go. I think you can see what's about to happen. We're going to very quickly use this product rule right here. We could have our first function, negative u, and then we'd say, gosh, now I've got to take the derivative of x e to the negative x, but here's the cool thing, you already did that right up here, didn't you? So it's not like you have to redo that work. It's already been done. Just recopy it down. That's one of those little benefits. But then we're going to have to say, well, now I have to multiply by, you took negative u multiplied to the derivative of x e to the negative x. Now take the derivative of negative u. That's going to be a negative u prime x e to the negative x. And then we're going to take the derivative of this u e to the negative x. Well, we need the product rule once again. That's going to be u times the derivative here. It's going to be a negative u e to the negative x. But then we'll take the derivative of our first function. That's u prime e to the negative x. And wow, here we go yet again. This is what makes this problem in particular rather meaty and long. Now we're going to take the derivative of this u prime x to the e to the negative x right here. And again, we need a product rule, but here's that reoccurring appearance. We already did that derivative earlier. So thank goodness as we took the derivative of that x e to the negative x, we've got that here. And then finishing up the product rule, we'll take the derivative of u prime and get u double prime x e to the negative x. So at this point, guys, we've got some cleaning up to do. We've got quite a bit of cleaning up to do. And let's see if we can do that right now. As we distribute, let's see, a negative times a negative is actually going to get us a positive. So we'll have a u x e to the negative x. Then we'll have a negative u e to the negative x. Here we'll have a negative u prime x e to the negative x plus a negative u e to the negative x plus a u prime e to the negative x. Distribute here, my goodness, a negative u prime x e to the negative x plus a u prime e to the negative x. And then finally, a u double prime x e to the negative x. And Wow, as we're just trying to put this all together, now it's a matter of looking for like terms. I'm going to take my first term right here, the ux e to the negative x, and say, is there another ux e to the negative x to combine it with? The answer is no. However, when we come to this next one, the negative u e to the negative x, you're going to say, wait a minute, I see another one right there. And if I'm not mistaken, I think those are the only ones. So we're going to say this is a minus 2u e to the negative x. And then we'll say, well, let's look for the next one. Look for a negative u prime x to the e to the negative x. And we've got another one of those right here, you can see. So that's rather nice. And we can say, hey, we can make that a minus 2 u prime x e to the negative x. Then we come over here to the u prime. Let me change this color a little bit. And if we had a u prime e to the negative x, here's another u prime e to the negative x. Well, there are two of them. So I'll say a plus 2 u prime e to the negative x. And then finally, we only have one of these, a u double prime x e to the negative x. Wow. So we've done quite a bit of work here. What is this all for? Well, my goodness, you hopefully remember you now have y double prime, y prime, and y, but the original differential equation was y double prime plus 2y prime, and let me put a little bit of extra space here, you can see why we're going to do that, plus a y equaled 0. We're going to substitute this all in. Look, for y double prime, we'll have a ux e to the negative x minus 2u e to the negative x minus 2u prime x e to the negative x plus 2u prime e to the negative x plus, make sure that jumps out, u double prime x e to the negative x. Then we're going to double y prime. Well, y prime, I'm going to highlight in green right here. We have to double that, however, because as we're plugging that in, you can see it's a plus 2. So I'm going to turn that into a minus 2 ux e to the negative x plus a 2u e to the negative x plus a 2u prime x e to the negative x. Finally, we're going to say, what about y? Well, y was just u x e to the negative x. So we have a u x e to the negative x. All of this was equal to 0. Well, this just looks crazy, and sometimes you're going to get this. You're going to see things that just get excessively messy. Here's the good news. You look to see what you can cancel out. First term here, ux e to the negative x is going to cancel with this one right here. You can see I've got a negative 2u e to the negative x. Here's a positive 2u e to the negative x. These are gone. Look, I've got a minus 2u prime x e to the negative x. I've got a plus 2u prime x e to the negative x over here. So things are cleaning up. Things really are getting fixed up in a hurry. And, you know, as we continue to look here, if there's something else that might be able to get canceled out, you know, as we're looking right here, we've got a 2u prime e to the negative x. That looks like that's all by itself. We've got a u double prime. And then look right here, we had a minus 2ux e to the negative x. You know what? Forgive me. I very quickly started this incorrectly. My apologies. Look at this. The ux e to the negative x and this ux e to the negative x, that would add up to a 2ux e to the negative x. It's going to cancel this thing right here. So my apologies. What I started off, two positive terms aren't going to cancel out, but they're going to make a positive 2ux e to the negative x, which canceled here. So after a lot of canceling, and this is kind of mind-blowing, we'll be left with u double prime x e to the negative x plus 2u prime e to the negative x equals 0. So wow, look at that. I'm going to divide everything by e to the negative x. It's certainly a nice way to clean this up. And on the sun, you'll have u double prime x plus 2u prime equals 0. How about we divide everything by an x? And hey, it won't take you too long to see nicely that you are left with this. So guys, this is one of those problems that can get kind of painstakingly complicated, but it's just gotten better now that things have canceled out. Let's let w stand for u prime, and that means w prime would be u double prime. And why are we doing this? Well, I think you can see it's now going back to a chapter 2 integrating factor problem. What's our integrating factor? Well, it's going to be e to this 2 over x dx, and this becomes e to the 2 ln of x. But as we bump that up to a 2 power, a second power, this just becomes x squared. Look at that. That's your integrating factor. So I'm going to multiply x squared everywhere in this problem. And we're going to be left with x squared w prime. Here this becomes 2xw is equal to 0. And guys, here's the great thing. This is really a product rule of x squared times w, isn't it? And right now we can go ahead and integrate. And this just becomes x squared w. This just becomes some constant. And tell you what, we can continue doing some work right up here. W would be some constant all over x squared. Now w, remember what we did here. W honestly was just filling in for u prime. It was there to reduce order and to turn this into a first derivative differential equation. As we go ahead and we integrate with respect to x, this becomes a u. This we bump up 1 power. It's going to become x to the negative 1, so we'll have c1 x to the negative 1 plus some other constant. But we're going to say real quickly, let's let c1 be equal to 1 and c2 equals 0. And what will you really have? U's equal to then x to the negative 1, or u is going to equal 1 over x. Well, remember what started this whole process out. We said that we believed that y was equal to u times x e to the negative x. We were told this was our first solution, and now we found out what u is. It's 1 over x. And hey, look at that. This is your second solution right here, e to the negative x. They might ask for a second solution. But for our general solution here, we're going to say that, well, we've got our first solution that they told us about. But then we can say, you know what, we just found our second one right here. So that wraps up 4.2. Day 1.